In the first standard of Unit 4, we're going to be dealing with exponential functions. An exponential function is a function in which the power is the variable. The variable is the exponent of a constant, which is called the base. Here's an example of an exponential function. Y equals AB to the x power. Here are a few examples. 6 to the s power is 216. Is an exponential equation slash function because the variable s is the exponent of a constant base 6. Again, if the variable is the exponent, it is an exponential function. 212 equals t to the fourth power is not an exponential equation or function because the variable t is the base of the expression and the exponent 4 is a exponent. The same properties of numbers and properties of equality used to isolate the variable in a linear equation can be applied to solve nonlinear equations as well. Okay, so I'm going to do a few examples here. So my first problem is 4 times 2 to the x power plus 1 equals 17. I'm going to use the same properties and same rules as a linear expression or two-step equation. So my first step is subtract 1 to both sides, and I get 16. I'm now going to rewrite 4 times 2 to the x power equals 16. The only thing I can do is divide by 4, and I get 2 to the x power equals 4. Now, the only difference is instead of doing an operation, you have to think about the rules of perfect squares. 2 to the what power equals 4. In this case, x equals 2. So the exponent in this problem is 2. Second, this is like function notation. I'm giving you the x value, and all I'm doing is plugging it in. Half times 6 to the second power, order of operations. 6 to the second power, and I get half times 36. My answer is 18. Example number 3. I'm giving you the exponent value, in this case, n equals 5, so I plug that in. 10 times 2 to the 5th power. 2 to the 5th power is 32, so 10 times 32, and I get 320. Now, here are 4 word problem examples. Tina raised the number 3 to a power. Okay, that's easy. 3 to the x power, and then added 19 to the result. She obtained the sum of 100. So my equation is 3 to the x power plus 19 equals 100. Now, I solve for x. Subtract 19 to both sides. 3 to the x power equals 81. And now, you have to think to yourself, what power would the x be? 3 to the what power? Well, 3 to the first power is 3. 3 squared is 9. 3 to the third power is 27. 3 to the fourth power is 81. So in this case, x equals 4. Number 5. There are 256 teams in a regular soccer tournament. During each round, half the teams are eliminated. How many rounds must be played until the final championship game between the last 2 teams? So this one is a little tricky, but it's a half to the nth power times 256 equals 2 because I'm trying to get down to the last 2 teams. Divide 256 to both sides, and I get 1 over 128. I'm going to erase this and rewrite it. 1/2 to the nth power equals 1 over 128. Now, it doesn't matter how many times 1 gets multiplied to itself, so I don't have to worry about that. But what I do have to realize is what times 2, what power would I take 2 to get 128? 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. Fifth power 32. 6th power, 64. 7th power, 128. So in this case, n equals 7. Last example. The number of bacteria in a petri dish doubles each hour. At the start of an experiment, there were 300 bacteria in the dish. When the scientists checked again, there were 4,800 bacteria. How much time had passed? So it doubles each hour. So our expression will be 300 times 2 to the h power, h representing hours, equals 4,800. Now, first step, divide 300 to both sides. And I get 2 to the h power equals 16. Well, that's easy. 2 to the 4th power equals 16. So h equals 4. So it was 4 hours.